It says syntax error actually. That's really classy. Okay. Anyway, it's a pi, but.
Yeah, but it's
like Mr. Anyway. Okay. Alright, so this is my last one. Now, before I show you what the substitution is, they will tell you what the substitution is. But before I give it to you, what would you guess the substitution ought to be? Because there's actually enough information in this to sort of guess. What would you put there? By the way, I'll give you a tip. We're in harder trig integrals, right? So it will be a trig function of some kind. The question is which one? It's going to be sine. Okay, here's how I know. Number one, there's a square root here. Okay, so it's either going to be sine or cosine. If it was tan, there'd be no square root. Okay, but secondly, it's positive, and sine's the one that's climbing. Okay, but anyway, they'll tell you what it is. So in a sense, this doesn't matter. But in fact, it's the same as the last question. X equals 2 sine theta. Okay. Now you'll notice this is an indefinite integral, so that's sweet. I don't have to worry about boundaries, but I still have to worry about this dx business. Okay. So again, I'll say the actual equation I've got there, the actual thing I'm integrating rather, is it's got no x's, it's got x squared though. Okay. So I'll square that. That gives me the same thing, same result I had before. I'll differentiate so that I can sub dx out, and again I get the same result as before. Okay, but this x squared on the top rather complicates things. Okay, so let's have a go, shall we? I've got all the pieces I need to sub out. So 4 sine squared is what goes on the top. Sorry, yeah, that's right, 4 sine squared. That dx as well is also on the top, really. So I'm going to put that as well. That's 2 cos theta d theta. 2 cos theta d theta. Okay. And that's all over 4 plus 4 sine squared theta, just like it was in the last case. Okay. Now, let's have a look at, wait, hold on a second, 4 plus? Sorry, that's a minus. That wouldn't work. My brain was thinking, wait, that's not the right identity. Okay, minor change. Now, just like before, this is going to turn into, that 4 when you bring it out will become a 2 outside the square root. And then you'll have 1 minus sine squared, which is just cos, right? So I'm going to get 2 cos, which is what I have here as well. Okay, so this is, I'll just write out the whole thing. 2 cos theta d theta on 2 cos theta. Okay, so you cancel. And you're thinking, sweet, what do you mean this is harder than the previous one? Okay, well let's keep going and see what happens. Sine squared, again we've got to use our double angle formula to simplify this into something I can integrate. Okay, so this is going to be 4 times half what? 1 minus cos 2x. Okay, so that 4 times a half will be 2. 1 minus cos 2x. Sorry, theta. D theta. Okay. Okay, we're almost there. Again, that 2 will actually be useful to me because when I use reverse chain rule, that's just become sine 2 theta. Okay, so 2 theta minus sine 2 theta plus c. Okay, now, usually we tend to think of indefinite integrals as less work than definite integrals because definite integrals are the same thing, but you just have to put in some values, right? So it's just a few extra steps you have to do. But here, indefinite integrals are actually more work. Can anyone see why?
You have the square root.
Yeah, I'm not done yet, right? This answer here, it's all integrated and that kind of thing, but it's still in terms of this magic substitution that I just introduced, okay? Has nothing to do with the x's that the original question was in terms of, okay? So I've got to do some legwork here, and there's kind of a fair bit, to actually get this back in terms of x's, okay? So, let's continue over here. I've got a 2 theta and I've got a sine 2 theta. Let's deal with the first one first. How do I get rid of theta? My substitution was this, right? So what am I going to have to do to get theta into it? Yeah, I'm going to have to use inverse functions, right? So I'll take the 2 over the other side. This leads to x on 2 is sine theta, right? So therefore theta is this, okay? Alright, so far so good. So I can substitute that theta there as 2 sine inverse of x on 2. Okay. Alright, so far so good. Now I've got a sine 2 theta. Now, I could just say that's sine times 2 sine inverse x on 2. Okay, I could do that, but for reasons which I hope will become clear in about 30 seconds, it's actually a bit counterintuitive to do that. So I'm actually going to first expand sine 2 theta. You all know the substitution for the expansion for sine 2 theta. It's 2 sine theta cos theta, right? And don't forget your constant keeps on hanging on, okay? Okay, now, I'm almost there. When I put in theta here, right, it's going to be sine inverse of x on 2. 2 sine inverse of x on 2 minus, alright, this is going to get rather large, so stay with me, sine of, actually I should probably make them square. Sine of sine inverse x on 2 and cos of sine inverse x on 2. Plus our poor Lerner constant, okay? So, what do I do now?